In this unit, we will explore various settings available for the heat solver. Under the General tab of the Heat Solver Property Editor window, the Simulation Region parameter selects which of the simulation regions from the objects tree will be used by the solver. Note that only one simulation region can be assigned to a solver at a time. The solver mode and solver physics can also be selected under the same tab. By default, the solver mode is set to a steady state and thermal only is chosen as the solver physics. For more information about different solver mode and physics options, please refer to their corresponding units in the course. The norm length parameter is only available in two-dimensional simulations. This parameter is used to define the length of the simulated structure in the third dimension when the simulation region is two-dimensional. This information is needed by the solver to calculate volume-dependent parameters such as net dissipated heat power. Under the Mesh tab, the global mesh constraints define the degree of refinement of the simulation mesh. The mean and max edge length set the minimum and maximum edge length of the triangular or tetrahedral elements used in this finite element mesh. Smaller values mean a more refined mesh and possibly more accurate results at the expense of increased simulation time and memory. Max refinement steps in the auto refinement settings sets the maximum number of iterations in the mesh refinement process. A larger number here means that the solver is more likely to refine the mesh up to the limits defined by the local or global mesh constraints. Local mesh constraint objects will be covered later in the course. It is important to note that during the meshing process, if the meshing algorithm reaches the value set by the max refinement steps and the target level of refinement specified by the global and local mesh constraints hasn't been achieved yet, the mesh refinement will stop and the resulting mesh may not be adequately refined. In this case, the user will receive a warning in the log file. It is recommended to increase the number of max refinement steps as you change the mesh constraints toward a more refined mesh. Sensitivity controls the sensitivity of automatic mesh refinement to changes in properties such as imported heat generation profile in the simulated structure. A higher sensitivity can result in a better representation of smaller changes in these properties by using a more refined mesh in the areas where those changes happen. The advanced mesh options should be left at their default setting in most cases and are beyond the scope of this course. The Transient tab includes settings for transient heat simulation and is covered in the Transient Simulation subsection of this course. The Results tab contains a list of all the results that can be recorded during a heat simulation. One can pick to enable or disable one or more of the results to reduce file size after the simulation is run. The tab also contains basic information about the available results such as their units and descriptions. Finally, advanced settings for heat solver are located under the Advanced tab. These settings should be kept at their default values in most simulations and are beyond the scope of this course.